Hi, in this video I'll be covering and explaining what a head node is in a cluster, the characteristics and policies for the DEAC head nodes. This way should give you a better sense of the head node component of the cluster and how it is used here at Wake Forest. In this simple model we have a classical Beowulf cluster designing where you only have a single head node connected to n number of computational nodes. The purpose of the single node is to be the master node to the whole cluster. For this case, it becomes a single point of managing all the computational resources of the system. The first rule of thumb in designing a cluster is not to make the head node part of the computational pool, mainly because other people are using those same resources. The problem with this cluster model is that it can bottleneck once the number of users increase. It is clearly that the head node can be overwhelmed in trying to provide all the requested resources to every user connected to the cluster. Usually this will slow down the head node and in worst cases crash it. So going back to the model, it becomes more favorable to the many users problem by adding more head nodes and providing more than one gateway to access the cluster. This way the load throughout the head nodes can be more or less evenly balanced and decrease the possibilities of slowing down any of the machines, or again, crash the head nodes. For this model of the head node, you will find that the most important services for the cluster are found on that single head node. As seen already, it is the central point of connectivity to the system. It is the place in where all the users' files are stored and transferred. It's where the scheduling mechanism resides, such as Torque and Maui or Slurm. And most clusters have monitoring systems in order to keep administrative folks like us in our feet and check that the system is alive and kicking. So the head node must also know all the configurations of the computational nodes in the system, and it is important and is sometimes part of the monitoring system in order to keep all the machines that are communicating and checking in to the head node. And finally, the head node will have an identical operating system environment, the same ones that you would find in the computational nodes. Now this makes it a lot easier for the administrative folks and for the users that they will have the same environment throughout the whole system. In this diagram, you have a representation of a high-level topology of the DEAC cluster. As you can see, it consists of 3 head nodes, and the purpose of those 3 head nodes, as mentioned before, is to alleviate the user connectivity load to the cluster. And it also provides more than one head node to test programs before submitting any of the jobs to the cluster. These 3 head nodes of the DEAC cluster are configured to the Torque scheduler, in where most of you already run your PBS scripts, so there's no news there. But very few know about the 4th head node, in where it is configured to the Slurm scheduler. If you're not familiar with Slurm, you can check the Slurm videos once they become available. You can also check our wiki page for Slurm information. The upcoming configuration component of the head nodes is that we will reduce the head node count down back to 3. The scheduling process will then be configured only to be Slurm scheduling head nodes. The name of the new head nodes are yet to be determined, but we'll publish those once they become available. But for simplicity for making this video, I'll keep referencing them as in the same name as they are today. One good thing to know is the specifications of our head nodes, and the hardware specifications should give you a better sense to the host that you're actually logging into. Our traditional Torque head nodes right now consist of 8 physical cores with a RAM space of 96 gigs and swap space of 8 gigs. In case you find yourself in the Slurm head node, it should also give you a good sense of the hardware specs. In this case, the number of cores is 8 as well. However, we have less amount of RAM for this head node. So if you're testing any of your Slurm scripts or programs that you want to run in Slurm, just be considerate. When a user connects to the cluster through other terminals such as PuTTY or a Linux terminal command line, you will have a screen that looks like the one in the animation. By using the command pwd, which displays your current working directory, it should show you your home directory in the DEAC cluster. The main message about using your home directory is that the directory is there for testing purposes only. Put your files there that you want to test and have short runs before you submit your jobs to the cluster. Don't run jobs that read and write to and from your home directory. We don't also want you to actually have your jobs reading and writing from your home directory. The reason is because it can slow down the file system and slow down everybody who's connected to that particular head node. And when testing your programs, make sure you do not allocate all 8 cores or allocate all the available RAM in there. Remember, you're sharing those resources with other users. And your actual job should run any of the reads and writes into and from your research path, which is not the home path in which you connect to the head node. The research path looks a little bit different from the home directory. The current format of those in Renola campus, the directory will start with WFURC and a number associated with it. Then you will have your advisors folder, then followed by your username. The medical school users, you will have your research path under the ISOLAN and WFU HPC folders before getting to your advisors and research labs directories. And then you will see your folder name under your own username. These paths are used to place and generate the data you will need for your simulations and any file generated by those simulations or jobs in the cluster. Make sure you utilize the research path because each file system will have more disk space compared to your home directories when you connect to the cluster. So remember, if you need any support, please email us at DEACHelp, or you can go to our website for more information, and you can also follow us on Twitter. Thanks for watching.